Hey everybody, welcome to the 5th video on square roots and Pythagorean theorem. This one is titled No Calcs. That means no calculators allowed for this section. You have to be able to do this without a calculator. So put it away now. Yes, I'm looking at you. I know it's right in front of you. Put it away. You cannot use your calculator in this section. That's why there's a sad face over top of mine as well. All right, no calculators. Really don't use a calculator here because you need to be able to use it without. You will have tests where you cannot use calculators, so don't cheat your way here because yes, you can do it without a calculator or with a calculator, but you're just gonna run into trouble later when you have to prove that you can do it without. So it's not that bad, I promise. You will get used to it, and I've got lots of practice here. That also means it's going to be slightly longer than 10 minutes. It'd probably be 15 or maybe even 20 because it is a tougher one. But let's dig right into it and follow along and make sure you do practice this stuff. Okay, solving square roots without calculators. We're going to start off with the easiest one ever, square root of 1. Remember, what we're doing here is we're trying to find squares. We're trying to pair off our factors into squares that we can break it down. Remember that we have square, which is the area inside, and the root is just one side. So if you're looking at something like 4 on the inside, then we know that the side lengths are 2. If we have the area of 1, then the side lengths are just 1 and 1. So easiest question ever, square root of 1, well, it's just going to be 1. So the answer here is 1. Square root of 144. So now I'm going to have to start to show you how to break things down into smaller pieces in an easier way. We can use those things that we were doing before. We can divide down. That's kind of a pain in the butt. I mean, we can do it, definitely. And what we're going to find in the end is we'll have 2 times 2 times 3 times 2 times 2 times 3. But this is really just a square that is easy enough to memorize. It's just 12. You should remember some of those from those charts that you had before when we were learning squares. 12 times 12 is 144. And if you don't believe me, you can break that down yourself. Oops. So 144, break it down to two different things. 2 and whatever that is divided by 2. What would it be? It would be 72. Is that right? Yeah, sounds right. Okay, and break that down further. Let's break that down into 2. So that would be 36. Break it down again, and I should be circling these. 36 divided by 2 is 18. So now we have 3 and 6. Okay, and now we have 2 and 3. So we have 2, 2, 2, 2, 3, 3. So 2 times 2 is 4. 4 times 3 is 12. 2 times 2 times 3 is 12. So yes, it is 12. Okay. This one, these ones I love. They look real scary, but they're really not. So all these ones with zeros, the trick to dealing with these is you can split off that 4, okay? So we have a 4 here. We're going to just move that 4 away because 4 times 10,000 is the same thing as 40,000. Wouldn't you agree? You should be nodding your head right now. Yes, I agree, Mr. E. 4 times 10,000 is 40,000. Okay, 4 here is the same as 2 times 2. Easy enough, so we'll just call that 2 times 2 instead of 4, which is also 2 squared, but we'll get there. 1, 0, 0, 0. How many zeros do we have? We have 4 zeros. So the nice thing about these numbers like 10, 100, 1,000, 10,000, 100,000 is you can really just count the number of zeros and then split them up. So 10,000 here, I'm actually going to split up to being 100 times 100. Same number of zeros. 1, 2, and 1, 2. Okay? And they will multiply together to get 10,000. So now what I have, breaking that down, is I have a set of 2 squared, times a set of 100, 100 squared. And remember that a square root is the opposite operation of a square. So the cool thing here is now that I've paired them up into their little groups of 2's here, I can say, well, I'm going to cancel the square with the square root, and this 2 is going to go to the outside of the square root now. So I have 2, and then same thing here. The square is gone because it's the opposite, but that still leaves me with the 100 that goes to the outside. So I have 2 times 100 after I've dealt with the squares and square roots. You can only get rid of things from the square root if they had a square because it's opposite operations. If I had 2 squared times 100, I would not be able to get rid of that 100. It would still be square root 100. Okay, so 2 times 100, that's really hard. No, not really. 2 times 100 is 200, so that is my final answer here. I should be doing some boxes around there. Oh, here's another one. We have the square root of 43 squared. That one you should be looking at it right away saying, hey, that's a square, and there's a square root. Those are opposite operations, so let's just get rid of them, and 43 comes to the outside, so sounds like I'm narrating a football game. 43 is my final answer. Okay, here's a chance for you to practice, and please, 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 I know you don't always do it, but please practice these. Super important. All right, practice setting them into pairs and using opposite operations on square and square root and coming to a final answer. Pause the video now, give it a shot. Okay, hopefully you did the practice here and you got something like this. So what I did is I just, for simplicity, I like to keep them in pairs so I could show it to you very well here. My 2's, my 3's match up. I have a pair, and now I have a square of each, and they're going to be exiting my square root because I did the opposite operations, but I'm still left with 2 times 3, and 2 times 3 is just 6. Here we have 10,000. Remember, 10,000 has 4 zeros, so I can split those up to 100 and 100. 100 times 100 is just 100 squared. The same thing multiplied by itself twice. That's an opposite operation with the square root, so this 100 is going to come to the outside, and all I'm left with is 100. Here I have, what is that, 1 million? Yep, 1 million. Okay, 6 zeros. So 1, 2, 3 here, 1, 2, 3 here, and that creates 1,000 and 1,000. 1,000 times 1,000 is 1,000 squared. Opposite operations, this guy comes out, and I'm left with 1,000 as my final answer. Here's some more practice. This one is not a show you know, so you can listen and watch. I know when I have something like 9, I know that it's a perfect square because that's a very familiar one. And I know that I can just say that 9 is the same as 3 squared. 49. 49, is that a perfect square? You should be nodding your head. Yes, it is a perfect square. It is 7 squared, is it not? And therefore, now I have opposite operations. These guys come to the outside, so I have 3 times 7, and that is just 21. Here we have 164 more nice perfect squares for us to deal with. We have the square root now of 10 squared times 8 squared. Ones that you should have memorized. So these get canceled out and they come to the outside. This is so messy, but basically we have 10 times 8, and 10 times 8 is 80. 3, 6, 0, 0. Looks scary, it's not. Remember that the big trick here is let's get that 36 separate, and then we're going to multiply it by 1 and however many zeros were left over. So you should agree with me that 36 times 100 just makes 3,600. Okay, now let's look at these, which are perfect squares. 36 is 6 squared, and 100 is 10 squared. So these squares will cancel out. These guys will come to the outside, and I have 6 times 10, which is 60. Starting not to look bad, right? I mean, these are the ones that are easy to work with no calculators. That's not always the case, but you should always be able to do it with the tree or the division techniques, breaking it up into pieces, and it will work out that way. Maybe a little bit longer, but you should be able to do any of these problems that we're doing without a calculator just fine. Okay, show you know. Here's where you practice, give it a shot, pause the video, and come back to me and check your answer. Okay, here we go. This is what I came up with, my 900. I did it a different way here, but I'm going to, on the side, show you that same technique that I told you to do before. So what I prefer to do is you take that number right here, you split it from the zeros, and then you can just look at it like those perfect squares that you already know. So you got 3 squared times 10 squared, and that is 3 times 10, which is 30. And the reason I did it like this is just to model that it's the same thing. If you broke down 900 with the tree method or the division method or whatever into all the individual pieces, well, they still pair off. It's the same thing. The number doesn't change. So whatever method you use or whatever strategies you use, you'll come to the same answer. So doing it this way just saves so much more time, and it's way smarter. So do it the good way, and if all else fails, you have a backup plan. Okay, this is the easiest thing. 31 times 31, it's just 31 squared. Cancels out, and we have 31 as our answer. I think we're getting close to the end now, finally. So 32,400. Remember, what I like to do is break that up. 32 and 324, sorry, times 100. 324, I don't really know if that's a perfect square. It might be. I don't know. So I'm actually going to have to break that down. All right, so 324. Let's use the other method here. Oh, whoops, what did I do here? 324 divided by 2. Well, let's see. 300 divided by 2 would be 150. 320 divided by 2 would therefore be 160. So this would be 162. I'm just doing the math in my head. So now 162. Well, 160 divided by 2 would be 80. So this looks like it would be 81. And I can break this down. That's going to be breaking down. This is now easier stuff. Divided by 3, 9, 3, 3, 3, 1. All right, so now I've broken down to all the pieces, and I have a pair here, a pair here, a pair here. So I can actually put these pairs in now. 2 squared times 3 squared times 3 squared times 10 squared. I didn't have a calculator to use here. All I had to do was some basic division. And that allows me to cancel all these things out. Now my square root is gone, and all these things came to the outside. So I'm left with 2 times 3 times 3 times 10. Whew. That was quite the pain. All right. And my original question was, is 324 a square number? Well, turns out it is. It's the square number of 2 times 3 times 3, which is, what, 18. 18 squared is 324. Good to know. So if I had actually known that from the start, instead of doing all this work, I could have gotten to the same answer just by saying, well, 18 squared times 10 squared is equal to 18 times 10 is equal to 180. I would have gotten it that way. Much simpler. So memorizing squares, definitely a bonus. Now that I know that information, though, look at this one over here. That's going to make it so much easier. Let me put a, whoops. Oh, that was a terrible line. What kind of line is that? That's still terrible, but it'll work. Okay. Oh, okay. Nice square root, Mr. E. 324 times how many zeros? 1, 2, 3, 4 zeros. Now I know that 324 is actually 18 squared, so I can shortcut that now because I know that. And 1, 2, 3, 4 zeros means 100 times 100, or 100 squared. Let me rewrite that now. 18 squared times 100 squared. These are going to cancel out. Opposite operations. These guys come to the outside of the square root, so all I'm left with is 18 times 100, which is 1800. 1800 is my final answer there, just like 180 is my final answer there. Okay, I think we're getting close. 324000000. Oh boy, that looks fun for you. I'm sure you're going to have a blast with that one. But thankfully you have some notes here. You know 324 is 18 squared, and you know you can do with any of these big 100 kind of numbers. And you've also seen a pattern here. Look at this. 180, 32400. 1800, so an extra zero here is 1, 2, 3, 4 zeros. So this went up by 2 zeros. Interesting. So now this is at 6 zeros. What is going to happen? Pause the video and work it out, and you will find out. Okay, here's the answer. Like you probably guessed, 1 extra zero. All right, and I did it by breaking up all the individual pieces just to show you it can be done there. But you know the smarter technique. So this is double checking work. You know that the smarter technique is, well, we already know that 324 is actually 18 squared, and this one is 1000 squared. So we can get these out, and we can just do 18 times 1000, which is 18,000. So don't do all this long work if you don't have to. I believe that is the last one. Oh man, I always say that, and it's never true. Oh, come on. Well, I did say it's going to be a long video. We're getting close to 20 minutes now, so let's try to rush it up here. 3 squared times 7 squared. So that's going to be 3 times 7, and 3 times 7 is 21. Here we have another pair. We have 2 squared and 11 squared under the square root. These cancel out. We have 2 times 11, and 2 times 11 is just 22. Last show you know. I'm pretty sure this time. Yep. Okay. Yeah, I kind of shouldn't have done that. I just showed you the answer. But I'm sure you'll be honest and you'll try this out yourself. So show you know, remember, pair it up and see what you can come up with here. Go ahead and pause now. Okay, here we go. So I paired them up, 2, 2, 3, 3, 6, 6, squared them off, and I end up with 36 here. These ones I paired up as well into squares. So 2 times 3 times 5 gives me 30, and that is the end. We are done. Not even, we have like 40 seconds left for 20 minutes. Should I just sing you a song? No, I'm not going to do that. All right. See you later.